All right, we're going to begin a unit on the application of exponentials. A common application is compound interest. So now, a lot of variables here. Let's just define everything here. A naught is your initial investment. So you have some money in your pocket, you go to the bank, and you deposit this amount. R is the interest rate. Just be careful with the rate of interest. In the formula, it's expressed as a decimal. N is the number of compounding periods per year. T is the number of years. And A is the amount you end up with. So, not worth, I'll say value. So I'll say value of the account. So, just to really quick summarize, you're depositing this much, it's accumulating this much interest, it's compounding interest this many times per year, and this is the amount of years that you leave it in a bank. Notice the value of n is repeating, so you're dividing the interest rate by n, and you're multiplying the number of years by n. So there's a couple of different types of compounding periods. So it can be compounded annually, and these are all different values of n. So I'll say values of n here. Annually, n equals 1, which means once per year. That's the amount of times the bank calculates interest on the account. You can have it performed weekly, and in that case n equals 52, because there's 52 weeks in a year. You can have it calculated monthly, n equals 12, quarterly. That means each quarter they're calculating interest, and there are 4 quarters in a year, therefore 4 compounding periods. And there are other types, but these are the most common. There's also daily, and there you have n equals 365. So now again, the value of n is telling you how many times the bank is calculating interest on the account. Okay, so now the most important thing is you got to memorize this formula, because unfortunately it's not provided for you on any exam. So you just have to memorize this formula, and we'll learn how to apply it now. Here's an example. Let's say $5,000 is deposited into an account that bears 2% interest annually. If the interest is compounded monthly, what's the value of the account after 3 years? So now the trick to this question, you see the word annually and you see the word monthly. The interest rate, 2%, is always an annual interest. That's why you see the words APR on like car commercials or mortgage commercials. APR is an annual percentage rate. It's the annual rate of interest. So interest rate is always annual, but it can be compounded more than once per year. So let's just pull out all of the pertinent information we need. And in order to determine what pertinent information we need, let's just write the formula. A equals A naught times 1 plus R over N to the NT power. So we need the value of A naught, which we have is 5,000. We need the interest rate. Now it's 2% in the question, but in the formula we're going to use the decimal value of 2%, so don't forget to convert it to 0.02. Interest is being compounded monthly, so there will be 12 periods, and T is 3 years. So now we have all the information we need to determine the value of the account after 3 years. Let's plug it in. A equals A naught 5,000 times 1 plus R, which is 0.02, divided by N, which is 12, to the 12 times 3 power. So now let's just take a look at what this is doing. The annual interest rate is 0.02. The reason you're dividing by 12 is because it's telling you how much interest will be calculated per period. Because by the end of the year, we will have accumulated 2% interest, which means we'll have to divide that 0.02 up to 12 different periods. So let's just recall the order of operations here. We have to clean this up first. We have to add 1. Then we have to raise it to the 36th power. The last thing we do is multiply by 5,000. Now, I would encourage you to use your answer function on the graphing calculator to prevent any rounding errors. So let me just show you what it's going to look like. The rest here is all calculator work. So the first thing I'm going to do is 0.02 divided by 12. 0.02 divided by 12. Now that's a repeating decimal. So I'm going to write something down on a paper, but I'm going to use the answer function to add 1. So I'm going to write 0.0017 on my paper, but that's not the number I'm going to use. I'm going to use the answer function on the calculator. So A equals 5,000 times 1 plus, and we said we're going to write 0.0017. But that's not the number I'm going to use, because that's a truncated decimal. This is an exact decimal. So I'm going to add 1 to that. Plus 1. Plus 1. Enter. Notice, I use the answer function plus 1. That says the previous line, add 1 to it. So now this number, 1.00166666 and change, is in here. So I want to raise that to the 36th power. I'm going to do that right away before I even write anything down. I'm going to use the answer function, which means raise this decimal to the 36th power. Enter. 1 point, and again, a lot of decimals here. So that's all of this to the 36th power. That's what I want to multiply by 5,000. So I'm going to use the answer function again. Times 5,000. Enter. So there's the value of the account. $5,308 and approximately 92 cents. $5,308 and 92 cents. So now, because the question's phrased as in sentence form, I'm going to provide an answer in sentence form. I'm going to say the value of the account is worth $5,308 and 92 cents after 3 years. So now, really quick, not in the question, but they could ask you how much interest was earned on the account. Well, if we started with 5,000 and we ended up with $5,308.92, then the amount of interest accrued we'll say earned is $308.92. Now again, the question didn't ask for this, but I'm just thinking ahead to think of all different types of questions that they could possibly ask us. They may ask us how much interest is earned, and in that case we started with 5,000, we ended up with a little over 5,300, therefore we ended up with a little more than $300. Let's do one more example. So now we have $10,000 being deposited into account that compounds interest weekly. So 10,000 is your A0. It's compounding interest weekly, 52 weeks in a year, at a rate of 3%. R equals 0.03. What's the value of the account after 5 years? T equals 5. Let's write the formula. A equals A0 times 1 plus R over N to the NT power. Take a look at the formula. The 1 is not being divided by N. The interest rate is. Because we want, after a year to pass, to have 3% interest. So every week, we're going to have a little bit of that interest so that after a year we'll have a total of 3%. So let's plug in our known information. A equals A naught, which is 10,000, times 1 plus R, which is 0.03, divided by N, which is 52, to the 52 times 5 power. So now what this information is telling us is that we have 260 compounding periods. 52 per year for 5 years. So the bank is going to recalculate the value 260 different times. So let's clean up inside of the parentheses here. Again, a lot of calculator work. We're going to divide the rate, 0.03, divided by 52. So now, just be careful with this. This is scientific notation. This is really saying 10 times 10 to the negative 4th power. And this is telling me to move the decimal point to the left 4 times. Okay, but again, I'm not writing that decimal anyway. I'm using the answer function and adding 1 to it, so plus 1. And notice the decimal point was moved to the left 4 times. 1, 2, 3, 4, for 3 zeros, 1, 2, 3 zeros. Okay, so that's the decimal I'm going to write. I'm not going to use that decimal. And I'm simply writing this decimal so I can determine which operation to perform next. So now, order of operations say I have to raise to the 260th power first. I'm not going to raise this decimal to that. That's simply helping me determine my procedure. I'm going to raise the answer to the 52 times 5 power. Maybe I should use parentheses there. Couldn't hurt. Enter. So that's that there. So I simply have to multiply by 10,000 now. So answer times 10,000. If you just push times, it'll automatically say answer. Otherwise, second negative is also an answer. So answer times 10,000. And the value of the account is $11,617.84. $11,617.84. So again, question was phrased in a sentence, and so is my answer. The value of the account is $11,617.84 after 5 years.